All right, this is page 408, number 19. The triangle has a 30-degree angle here, and it has a side of 10, and it has a right angle. And you're supposed to solve each triangle and give exact values. So what I'm going to do is I'm going to put a 60 in this corner, because if it's 30 in the top angle, the other angle has to be 60 because they add to 90. Then the next thing I'm going to do is I'm going to think about what it would look like if I had the rest of the equilateral triangle like this. So I know that if I have 10 on the hypotenuse over here, if this is 10, then this side would be 10, which means half of that would be 5. So I'm going to put a 5 here. Now you can do Pythagoras Theorem to find out what this value is. I've got x squared plus 5 squared equals 10 squared. X squared plus 25 equals 100. So x squared equals 75, and when I take the square root of both sides and simplify this, I get the square root of 25 times 3, and I get x equals 5 radical 3. You will find that every single time in a 30-60 triangle that the longer leg is going to be the shorter leg times radical 3. So I can erase this, and I'm going to write in 5 radical 3. That will always be the case. The shorter leg is half of the hypotenuse, so the 5 is half of the 10, and the longer leg is always going to be radical 3 times the shorter leg. Since I have all three sides of the triangle, the two legs and the hypotenuse, and I have the three angles, I have completed the problem which says give the exact values. When it says give the exact values, what it means is write this with the radical and don't put it in your calculator. All right, here's number 23 on page 408. And it says to give the 6 trig ratios for each acute angle. So in my triangle, I don't know this value, so I'm going to use Pythagoras Theorem, which says leg squared plus leg squared equals hypotenuse squared. So that gives me 25 plus x squared equals 34. So x squared equals 9, which means x is 3. So I'm going to erase this, and I'm going to put in a 3. All right, so next I have to find the trig values of all of those, of angles A and B. So the sine of A is going to be opposite over hypotenuse. So for angle A, the opposite side is 3, the hypotenuse is radical 34. So I've got 3 over radical 34, but I can't leave it like that. I have to rationalize it. So I will multiply by radical 34 over radical 34, and I will get 3 radical 34 over 34. For the cosine of A, that's adjacent over hypotenuse. So the adjacent side for angle A is 5, and the hypotenuse is 34. So I've got 5 over radical 34, and again I need to rationalize my denominator. So I end up with 5 radical 34 over 34. And then I need the tangent of A, and the tangent of A is going to be opposite over adjacent, or 3/5. So opposite over adjacent, that's 3/5. Okay, now it says to find the 6 trig values, so I'm going to continue with the cosecant of A, and the cosecant of A is going to be the reciprocal of the sine of A. So instead of 3 over radical 34, I'm going to write radical 34 over 3. Now, as I mentioned in class, it's a lot easier to take this and flip it than it is to take this and flip it, because then we would have to rationalize again. All right, then I look at the secant of A, and the secant of A is going to be the reciprocal of cosine. So instead of 5 over radical 34, I'm going to have radical 34 over 5. And then for the cotangent of A, that is going to be the reciprocal of the tangent of A, so that will be 5/3. So I will write 5/3. Now I do need to do all of those for b, so let me write these down. The sine of b, and then the cosine of b, the tangent of b, cosecant of b, secant of b, and cotangent of b. So we talked about in class how the sine of one angle is the same as the cosine of the other, because if I look at the sine of b, it's opposite over adjacent, so it's 5 over radical 34. Well, I know over here that 5 over radical 34 turns into 5 radical 34 over 34. So the sine is going to be 5 radical 34 over 34. When I look at the cosine of b, that is equal to the sine of a, because cosine of b is adjacent over hypotenuse, so adjacent over hypotenuse, and we know from here that 3 over radical 34 turns into 3 radical 34 over 34. So I've got 3 radical 34 over 34. Now tangent of b is going to be opposite over adjacent, so that's 5/3. So I can go down here and the cotangent would be 3/5. And then for the cosecant, we know that's reciprocal of sine, but we also know that the cosecant will be the same as the secant of a. Cosecant of b, secant of a, secant of b, cosecant of a. You can also take the sine value and flip it, but if you know the values and how they relate to each other, it's a little bit easier for the cosecant of b to just go to the secant of a. So radical 34 over 5. And the secant of b is the same as the cosecant of a, which is radical 34 over 3. Now, if you don't remember that for these right here, it's not a big deal, because the cosecant of b is just the reciprocal of this. The secant of b is the reciprocal of this. So there you have the values for a and for b. We have all 6 of these and all 6 of these.